In this section, we look at experimental design. So our units, subjects of the experiment. Treatment, we're going to do something like maybe give them a medicine or not give them a medicine, or give them the subject several different levels of it, like the amount of those may vary. And we have to keep in mind our explanatory variable and the response variable. So we're interested in the outcome. That's the response variable. So we're deliberately going to impose something called treatments on the experimental units to find out what happens. And we want to find the goal of the whole thing is the association. How does the treatment affect the response? So if we do an experiment, we actually can control many things and we get better evidence for causation. We have a control comparison group. That lets us judge how effective the treatment was. We randomize it to eliminate bias. We blind it to eliminate more bias. Placebo is when you have a dummy treatment, like a sugar pill. So if someone gives you a pill and says it'll help you, but in fact there's nothing in that pill as far as medication, it will actually many times make a person feel better. So the control group is the one that would receive the placebo. Now, if you have a treatment group that receives nothing, that would be the same thing, except there's just no placebo given. Randomization, we eliminate bias. We try to balance the groups on variables affect the response. We try to balance a group on lurking variables that may be unknown to you. Let's stop and have a example of that. So sometimes we have what's called confounding. Consider this experiment with the cold medication in 200 volunteer subjects, 100 men, 100 women. The men receive the drugs and the women don't. At the end of the test period, the men report fewer colds. In fact, there's a confounding variable in there. Gender actually can affect the response to medication. So you need to do something there. So there are absolutely no controls on this. You could have given half the women treatment, half a placebo. Same thing for the men. There's various things you could do here. So we're looking for causation. The control we talked about and the confounding effects sometimes that you have. And now we're going to look at some variability as well. So let's look at a particular example. So we're going to have this pretend company, Acme Medicine, and it's going to test the vaccine with 1,000 volunteers, 500 men and 500 women. The ages are going to range from 21 to 70. And we're going to look at 3 completely different designs. A randomized design, a randomized block design, and a matched pairs design. And here we go. First one, you simply randomly pick people to get the placebo and randomly pick people to get the vaccine and see what happens. The randomized block design does not do that. Remember, women actually may be more or less susceptible to certain things than men, or vice versa if you like to view it that way. So gender may actually be a lurking variable. In a randomized block design, you can split up the men and the women, give half of each group placebo and half of each group the vaccine, and you account for gender. We're not going to look at multiple treatments right here. Now, matched pairs design is a special case of randomized block design. For instance, you give somebody a treatment and you give someone else a placebo or no treatment, and then halfway through you switch it. That actually will tend to cancel out effects of the lurking variables. So here in this 1,000 group, we have 500 matched pairs. And match them on gender and age. For an example, first pair may be 2 women, both age 21. Second pair may be 2 women, age 22, and so on. So in that pair, you can give one of them placebo, one of them the medication. Some of these switch back and forth. So halfway through you might change it. In this case, you probably wouldn't. And we can have this down here. We'll test. And I'll let you pause this and see how you're doing it. Let me lift this up for you so you can see it better. Basically, it says which of these are true. Okay, so I'm going to pause this for you. So we just looked at a little bit of how we can design an experiment to balance on variables and to balance on the lurking variables that may be known or unknown to you. So general rules. You want to generalize it only to the population that is represented by the study. So if people volunteer to take a Pepsi versus Coke test, any results you get would only be valid for the type of people who would volunteer, and it's hard to know what that would be. So you need a control group. Those are the people taking a placebo or getting the usual treatment. And the treatments themselves are the experimental conditions. So if I'm giving one a medication and one not, those are the two treatments. You randomly assign the experimental units to it, and if someone else does the same study, he gets the same results, that is a positive indication. I'm going to pause it here, record the next one. I can get the cursor to work.